Alright, hello. I thought I was gonna do something a little bit different this time. I've been so engrossed in this new language that I'm making because I just think it's really fun. And yeah, I just wanted to get this out of my system here. Been using like AI to make kind of like a scripting language. Oops. So here, for example, you can use like it's sort of meant to be sort of like bash scripts, but with some programming stuff sprinkled in and more consistent. Well, I want basically the syntax is going to be sort of like zig, but then you can also call like commands immediately like this. And so yeah, the idea is to have, I guess, I don't know, I just don't like bash scripting. I mean, it fulfills a very good purpose, and that's why I want to make a new language. But it's mostly like started out as an experiment, but I just wanted to get this working a little bit more. So right now I'm working on the parser, and bear in mind also, like, a lot of this, like basically everything has been made by AI so far, but I hit my like AI limit. So now I have to go down in the nitty-gritty here and do stuff myself. But I think it's a good thing, because I think the AI was a little bit I don't know, schizophrenic, or maybe not schizophrenic is the wrong word here, but it basically, every time you tell it to do something, sometimes it spins off a different version of what you're trying to do. So we ended up having, one part of the compiler or whatever, the program that would run a script that was like, and that had its own parser, and then it also made another parser for just reading a script file. So it's like now we have two parsers, and it's like, okay, so I'm trying to go in here, understand what it has built so far, and yeah, right now I am so basically what we got so far, if I can see if I can run this here. So let's say we have this test file, and yeah, we get some unexpected token here, but I can tell Runic, which is the name of the language here, to, or not parse, print tokens, for example. So we can print all the tokens, for example. Now this is all like AI generated. That's why it's also trying to run the actual program. It's not supposed to run the program or run the script when you just want to print the tokens. But I haven't like fixed that. But it does print all the different tokens that we get here, and everything here is like AI generated. So keep that in mind here. And then I also have print AST, but that doesn't work right now apparently. So yeah, we're gonna get there. So right now it has trouble reading let statements, so that's what I'm trying to actually implement right now. And so here we got this parse statement function whose job is to parse every one of the statements. And so well, the idea is that basically kind of like bash, like every line is its own like statement, but then there's like special syntax if you want to have like multi-line stuff. We don't really have that right now. You can make like blocks, but not have like one statement is always like on one line right now, and that's why there's no like semicolons or anything like that. I'm considering the fact of actually introducing semicolons, because the parsing will get much easier. You can enable so much more versatility in how the program looks and so on. So yeah, so that is that is maybe a thing. I don't know. We'll see. Maybe it's not necessary, but it's gonna be. I think. Yeah, we'll see. I think especially because if you have a semicolon, when you actually run commands, then it's gonna be a lot clearer on what command, like, yeah, the command, if the command is gonna end here, or if you're gonna supply more arguments to the command, like that is a thing. Anyway, so here we got the parse statement. Now I have just before here I have implemented this parse let. So basically how this works is that, well, the AI made this Lexer stream thing, and so we can call Lexer next to get a token, which has been like you know, tokenized by the Lexer before for the source. So we can just try to get the next token, and then we can inspect the token and see what it is. Sometimes it has more like values and stuff in it. So basically here I am, the let is actually multiple things. It can be a let, which is a constant actually, and I might actually rename it const just to make it more similar to zig. We'll see. But we also have mute, which is you know, mutable instead of so it's kind of like in zig it would be const and var for variables, and constant. But this would be like let for, you know, the usual like let. It's kind of, you know, let is kind of, I don't know, it's more like mathematical, I guess, so it would be constant, I guess. But mute is mutables explicitly. Anyway, and then we have like this is kind of interesting, like, because I never thought about this, but this one, the AI actually made, like, you have a binding. Well, the binding is kind of the whole let binding statement. You know, you bind an identifier to some expression, so that's why we have the word binding here to know which context we are in. So we're parsing a binding pattern. And what is a pattern? Well, the pattern is either you just have an identifier, so that's normal, like you have like let, and here's the identifier equals expression. Discard. So this describes how the let is sort of defined. So this would be this would be just an underscore like this. So that's the discard. So that's basically saying that, yeah, we don't need this. And the tuple, this is like deconstruction. So you would have I don't know, some kind of syntax. I don't really have a syntax for this right now, so let's just I mean, in zig you would have set, like, you know, x y equals you know, some kind of position or something like that, and the record is just well, an object. But I'm not sure, we don't really have support for these two right now, but yeah, this is the idea here. Actually, I could put this over here like a comment, so you can see kind of like example. Oops. Maybe, I don't know. Oops. Okay, yeah, so that's the pattern. All right. And then we have like annotation, so you might have a type annotation if you want. I haven't made this actually yet, so I need to actually implement this one, type annotation. Some of these already exist, so I don't really know. This is like, I haven't inspected the whole full source code that AI has put forth here. But yeah, it's gonna be interesting here. So, and then we have the assign tag. and then we have some kind of expression that is the initialize or the initial, you know, expression that this let is gonna be, and then we just return this this object here that describes the let here. Okay, so but now I want to actually like use this in parse statements. So right now the parse statement basically only works for, I guess, this thing, parse if expression or primary. So right, we're checking if it's an if. Otherwise, we do a primary expression. Okay. I guess this is like the main thing. So we got some literals. Yeah. Identifiers. So basically, the let wouldn't really be an expression. It would be more like a statement, because you wouldn't be able to assign, for example, some kind of identifier to a let expression. That doesn't really work. So, well, I mean, technically you could make it work, but I won't really like allow that. So so this is actually not gonna work here. I would need some more different stuff here. So all right, so we would need to maybe parse an if expression or primary. So I would try to read maybe a, so if I were using like some kind of combinatoric you know, library, I would have, which you could make a function that is like parse one of or something like that, but I think for the purposes here I would just do straight up like imperative here for now, or procedure, or whatever it's gonna be called. So I think what we want to do is we want to have like maybe actually let's make the statement first, then if something goes wrong we will deallocate. Oh, we got like self arena allocator. I've been using allocator just straight up. Oh, that's the, okay. So we okay. I've been messing this up, I think. Well, maybe it doesn't matter that much. But anyway, it's important to have this the same allocator. So I will free this statement if something goes wrong. Okay, and then we will do maybe let I'm gonna parse maybe let there. So let's make that function. So the idea is if this fails, then we just you know, we have parse error, or we have a nullable let declaration. Now the problem here though is that I don't really wanna, I want to like restore the stream. I'm not sure if that's possible. So you can do a bunch of peaks, I guess, maybe. Consume if. I haven't really looked at this here. Hey Polaris7, how's it going? This looks really cool. Oh, nice. Yeah, I mean, I love making these kind of languages and learning more about it, because it just feels like it's pure programming fun. I don't know. Might be something wrong with it, but yeah, I really like it. Consume if. So the reason I need to go in here all the time, of course, the AI is generating a lot of stuff here, and I haven't really looked a lot into it. So what is this happening here? Oh, so it's only consuming if it's a certain tag. I see. And then we're returning a bool. It should really return the token, actually. I mean, what if you need more information? Is this even used? It is used in the tests. Okay. How are you today, by the way? I'm doing fine. I feel like you know, I was thinking like maybe I should work on the game a bit, but I was just into this too much. I was too much into working with this language here. I was just having too much fun. So I just need to get this out of my system. Start working on this a little bit. How are you, by the way? Thank you for asking. Right. Let's see. But what I need is a way to like go back or save the position. Like if we only had a string, what you could do is you could keep an index around that you would roll back. But right now we have this stream, and it has a lexer, active next depth. Parser can peek lexer, so the parser can peek ahead without materializing the entire token list. Huh. Oh, are we actually streaming this in here? Okay. So like when we want the next token, it's gonna like, it's like an iterator. It's like a pull action going on here. So, all right, you're good. Nice. So whenever we need the next token, this is gonna advance. But could we? So what does that mean then? It's doing that. I mean, maybe technically we could just restore this entire structure. We could make a snapshot by just copying this and going back, because it doesn't look like, well, okay, there's an index. Yeah, okay, I think what we can do is make a snapshot of everything here, and then when we want to restore the snapshot, we can just copy over all of these things, and that should reset the lexer. I mean, we could just take everything here. I don't think source is changing, like, we don't actually change the source, I don't think. We just make the index go further. Okay, so I'm gonna do this. I'm gonna have like snapshots. And it's simply returning itself. And then we're gonna have like restore. It's very simple actually, and this is basically just self equals snapshot. And then because Zig actually, yeah, it handles everything for us, it's gonna copy over all of these things. So this is like, it's very simple, and I just love this. This is very simple to do, to make this functionality here. And okay. Now Well, let's go back to where we want to be here. So I want to, because it's a maybe, so basically I want to make a snapshot here. Stream. Maybe even the stream needs this same functionality actually. Snapshot. Store. Except it's not Lexer, it's stream. Wait, no. There we go. So it's the same thing there. Oh. Okay, I'm just gonna call it S. Okay, so now we'll take a snapshot. And we will, if something goes wrong, we're gonna restore that. But let's see what we need to do here. So basically here we want to look at the next. Actually, okay, for the let it's kind of easy actually, because we just need to look at the next token and see if it's a let or a mute. So we actually didn't need this snapshot. We could just peek at the next token. We can do try self stream peek, and then we can say switch on the tag if it's a let or a mute. We will return parse let there. Otherwise we will return null. Actually we'll just return from here. Alright, okay, that was way easier there. We didn't need this snapshot here, I don't think. We'll see. So yeah, we need to do a try there. And right, so now we need that function as well. Okay, but let's do this first here. Hello Blue, how's it going? Yeah, I'm continuing with my little scripting language. One second, I'll be right back. Yeah, so basically I've been using AI to kind of launch coffee to launch like a I was just experimenting, you know, learning more about the AI tools and stuff, and I was like, well, let's try building a scripting language with AI. And I think I've learned a lot about how to use the AI to actually do stuff, because you can't just tell it to, hey, make a scripting language and make it work. It's gonna get a little bit and then it's gonna not complete it, basically, because it's too much of a task. So you have to know how to break it down. You can ask AI also to break it down, but then sometimes it makes like a weird job of actually breaking things down with stuff that you actually don't need or interested in. If you're just interested in I guess you could tell it also, basically you can give it some more guidance, because it's really gonna think like you're trying to build something that is gonna be like a product or something that you need to assemble a team, and you need to have documents describing to stakeholders and stuff like that. But yeah, so basically, yeah, I've been learning a lot of that, and in the process I made this program language, and yeah, I was just it's also because I I do wish I had this programming language. So it's also very, and I love making programming languages, or try to make them anyway. So I mean, okay, so right now we're improving the parser here. So let's see here. So parse statement, and also that's why a lot of this is like AI generated. So I have to like go in and really try to see. But it does, a lot of things make sense. It's just that it has made like multiple versions of the same thing, and I need to like consolidate that a little bit here. So so let's see here. So we have like a maybe let try. Okay, so now this is a nullable let declaration. So if we have that, we could probably just so basically, like if we have a maybe let, we have this let declaration, and we can return our statement, and we can populate it, and this is now a let declaration, and I guess we just put that there because that's what we need. Yeah. And we don't, oops. Yeah. All right. I think that's it. And then it might have a span as well. No? Wait. Oh, you have a span. Right. Alright, the let declaration already has a span. Okay. So basically the span is basically just telling where in the source code this is. Okay. Okay. So for a statement, we might have a let. If we have a let, we will set it to, the statement will be a let declaration. We return this statement. If it's not a let, we are down here, and we try to parse this if expression or primary instead. Okay, so so let's figure it out. So we need to make this parse maybe type annotation. Yes. Let's put you down here. Parse maybe type annotation, and we will get maybe a type expression. Okay. Do we actually have like skip type expression? Oh, so I think what AI did was it was just like, yeah, I'm not gonna implement this right now. So I'm just gonna implement a skipper for type expressions, because we don't really have a type system really. So it's just gonna skip it. I guess we'll try that actually. Skip type expression. Yeah, I think we'll do that. So to do implement an actual parser for type expressions. I'm just gonna see. Yeah, that's the module parser. So this is the kind of where the multiple personalities come in here. We have a module parser because it thought that since we import modules, it needed a separate parser for modules. But we don't. It's just the same thing. We don't need two different parsers in the same language. Hello, Not Slider. How's it going? How are you doing today? I'm good. Well, I'm making a language program scripting language here, so which I think is very fun. so yeah, I'm doing well. How are you doing? Okay, let's see. Yeah. So what is this doing? We are skipping a type expression while true. Well, okay. So first we're skipping. Well, this is. I think yeah. This is more for if you. No, but this has tokens. Para white space. New line. Okay, that's weird. So you can have new lines in type description. That doesn't make sense. I'll just make a version here that is like for. Actually, let's. I'm gonna rename you like underscore module to mark that as the sort of deprecated thing, and then you're gonna be that. We don't do white space there. We're doing good. Is your name really zoomed in, or have you small? It's zoomed in. It's zoomed in because so it's gonna be easier for people to see what's happening. All right. So it's kind of covered. It's actually, well, it's not zoomed in. Well, I guess you can call it zoomed in. It's the text is it's larger than what I would normally maybe have it. So it does take up like half my screen right now. But it's also good because I'm getting old and one of my eyes is starting to get fuzzy. So if I go back to like small text, I'm not going to be able to read it, maybe. I don't know. Anyway, so we're skipping times. So we're looking at the next function. So if it's a comma, parentheses, or a sign, we return. Interesting choice. Why would we care about those things? I would just look for a colon. If it's a colon, we want to skip. Yeah, so basically we're looking at the next one. If this is a colon, is that how you pronounce it, by the way? Because it sounds like I'm saying something else. Then we will skip the thing. So this is where we might want to do like a while true. If we don't have a colon, we actually just return. Or we don't do anything. So why would we need like a tag, or I mean a loop here? So if we have like a L parent, brace, bracket, tag, next token, skip next structure. Oh, I see. Okay, this makes sense. This makes sense. I guess this is for like if we are in. Okay, yeah, it does make sense actually. So basically, because we're looping, at first we're trying to look for this parent, brace, bracket, and we're skipping this nested structure, and then we continue, and then we basically well, then we might not even get to the parents, I guess. If we get an assign, that means in the case of a let, we've actually reached the end, I guess. Really, we should be able to just interpret the next tokens as a whole type expression, and then just return that. Else we just skip this. Okay, let's just see if this works. So I'll keep this as it is. I do want to add a colon thing though. maybe, or actually, I'm just gonna call this like, no, actually, you know what? I'll move this out, actually. Yeah. So I'll go to, what's the parse type expression or annotation? Skip type expression. So actually we will look for the thing first, else we can't do anything. There we go. And then over here we will do this. There we go. Oh, I see. This is like, it wants to be a pointer apparently. So there we go. And oh yeah, this needs to be stream next or peak. And you are try. Also stream peak. Stream next. And that's also because there's two different pipelines going on at the same time, so I have to change the interface or the API out to the non, I guess, deprecated one. Okay, and now you have some sort of error, parse error. I guess we'll do this one. See, the module parser errors, they actually are more a bit descriptive, but not sure if we actually need this level of description. Also, this one is right. So this one is also for modules. I'm gonna copy this and make a non-module version. There we go. Let's just do this. Next. Where's the error? There. So this would be parse error unexpected. And there we go. Expect token tag. This is stream next. All right. Okay, and at is going to be initializer end or span end. That's the whole declaration span. Location. Okay, there we go. Function with non-void. Right, we're not returning anything here. Okay, yeah. So I think we'll just return a null here, actually. So let's just, let's do it down here. We'll just return a null. And, right, so here we do this, we do that, there we go. All right. Oh, what's this? Meta. Okay, hang on. Let's do build. Ref. So we got a reference trace. So we got a error in some sort of standard library here, the meta. And what you need to do is like build, like to get where the error is, you have to run like with f reference trace, so you can find where it is. 269. Wait. 269. Size of. Oh, right. Okay, yeah, this needs to be destroy. Okay, yeah. Destroy for when you use create, you need to do destroy if you have like a single item pointer. If you have an array, you need to use free. There we go. Okay. Okay. I think that's it. We have all the. Yeah. So what we've done is we've turned let statements into ASTs. So let's see if this works now. And there we go. Now we get an AST for this file. Really cool. And you can see here we've got statement, a let declaration printing not implemented. Right. Okay. Expression statement. Oh yeah, that's the second thing. And then we have another statement. That looks weird. This should really be a command call, I think. Okay. Let's go to this one. Can it do this? No, it can't. Unexpected. Yeah, this is way too much. Yeah, this is a typed expression in itself, so it doesn't handle that. Okay, so right, but now we have let statements. We can even have let's do mutable. Let's try and make the print for this one. Which one is this? Render expression AST. This could really be like in them. This could be implemented in the actual type itself if you want. You can put it here or just use a function here, but I'm not really sure what's best because something tells me I don't want to pollute this part with a whole bunch of weird stuff either. Sometimes it's nice to have everything in one place, but it's also like, okay, but from which perspective? It's always the question. Like this, we have everything in one place from a, you know, render print the string perspective. So it's not always obvious. Render statement. Okay, so maybe this is the part where we wanna. I'll just copy this. Let declaration at. Oh, that's the span. Okay. Yes, and then render expression AST. I guess we want to say let render, so something like identifier. I'm just gonna write. That's really gonna be like render binding pattern. Oh, we already have. Okay. Pattern is let declaration pattern level. I guess +1. And we do have an expression, which is the initializer. And then we also might have a type. Oh. All right. Let's see what this gives us. Okay, there we go. So now we have 2 let declarations. Actually, we could also have like a mute is mutable. So binding result literal integer 5 float 2.5. Yeah. Okay. And we can also have render mutable. No. So basically, if so I want to have a print is mutable, and that's going to be is mutable. All right. And here we can see now. Oh, we need to increase the level. Alright, so this one is not mutable, this one is mutable. There we go. Just nice to get, to be able to, like, you know, debug this stuff. If it ever becomes a problem. There we go. Okay, so now what? What else do we want to be able to do? I think there's a lot of things missing here. It's like, it's weird because at one point, the AI actually made it able to like run a whole bunch of things, like declare functions. You could call functions, you could import modules, you could alias, you know, identifiers binding to other functions and call that on other modules as well. So you could do a whole bunch of stuff. Like there was even like there were optionals, if statements on optionals, and error statements. So I basically made AI do a whole bunch of stuff, but then it turned out that it never actually went through to make an AST parser. It just parsed the source code directly and executed it as it read it. I guess it probably interpreted my wish that I would like to build an interpreter to actually just interpret as it went on with the source output. That's kind of what we are doing right now, but now we also have a layer in between where we actually parse tokens. First we're parsing things into tokens now, and then making an AST first. We're not actually, well, we're not actually executing as we go. We are reading everything in as an AST, and then we execute the AST. Because it's like it's a scripting language, like it's like a what you could call like a, you know, it's more like a process orchestrator, I guess, type of language. So speed is not super important. Like it's not super important for it to be like super speedy. And also, you know, because of the fact it's like a toy language right now, so you know, you can always improve on those things later. There. Okay. Well, anyway. What do we need to do now, though? I want to have more statements. So basically, I think I'm gonna go. We have this features. So this is all AI generated. Basically, a bunch of examples or features that shows like, okay, what kind of things do we support here? So if you go to data semantics, for example, here we have a whole bunch of different things. So we have an import, we have, you know, a bunch of bindings here. We have a whole bunch of different expressions, strings, numbers, arrays, and anonymous structs here. And so everything here did work at one point, but now it doesn't because I'm currently in the process of remaking a bunch of stuff. Because yeah, the AI didn't really do what I wanted to do. But that's partly my fault as well. Like, I should have paid more attention to what was actually happening in the source code and then guided the AI earlier into the correct path. Because right now it just went ahead and did a whole bunch of stuff, and I wasted a whole bunch of AI power on the wrong path, right? So, but yeah, I can still use it as a inspiration to do nice stuff. But if I were to say now runic print ast on this file, it would not work because yeah, it fails on import here. So here we have like a let binding, and this import I think is not a valid expression. So I will go ahead and try to implement the import expression. Actually, it's a so-called primary expression, I guess. It's not really, I mean, primary. To me, that stands for a primary type. Or no, primitive. I was thinking of primitive. Primary. I'm not sure what primary means. Maybe that's a term, like a compiler term that I'm not familiar with. But yeah, this does not have support for imports. So I would need to actually, it's not gonna be an identifier. This is gonna be an import, keyword import, okay. And alloc expression. Maybe this is just for one. No, but then we have like parentheses. All right, so let's see. Well, this is recursive into expression, so that's fine. Okay, but maybe this, yeah, so then we don't put it here. I think this is mostly for these kind of values or identifiers. I'm gonna put it yeah, this is kind of weird. I'm just this parse if or expression or primary. Like, where is this used? Oh, it's used in parse if. What do you mean? You can have like an if and then an if inside the condition? Well, I guess if an if is an expression, then yes. But this, to me, this would just be an expression though. Why is this like, yeah, this, why is this not just an expression? Okay. And then, yeah, this becomes a bit unnecessary, I think. Expression, parse. Why is this like set? I don't understand. Let's just parse an expression. And we don't even have this function. Let's just remove this function. There we go. Alright. And here we like, we can switch on the tag. And if it's an if, we will return, actually let's just return based on the tag, parse if expression. If it's, I mean technically you can have function expressions, that would be kind of be like lambdas, I guess. Like functions as values that you can define on the fly. That would be kind of interesting. Also, we're gonna have to have closures. Man, it's gonna be fun to build. Actually, I'm kind of excited here. Async. No. Where's import? Pretty sure we had import somewhere. Oh, it's not working. Okay, that's why. Okay, so if we have an import, we're gonna parse an import expression. Otherwise, we're gonna parse a primary expression. There we go. So now we need to support the import expression. All of these also return an expression, which is important. Yeah, don't have anything. We don't have anything like a parse import expression yet, so we will have to make it. And this is going to be an expression. All right. So we've peaked on the import. So actually now we need to do expect token tag import, and then we're expecting a parentheses, and at some point we will be expecting a right parentheses. Now here we're gonna get the module name, which is gonna be parse string. Actually, strings are kind of weird, like for the module. All right. Yeah, because the string can be like interpolated. So would that work with modules? You wouldn't know which. I guess because we are working with interpreters, it could be fine. We could dynamically load in the module. We don't have to have the entire AST. That would though require that everything that depends on this module would have to have like a lazy types until we actually run the script and load the module that we need. So that is the issue here. So I think for now I'm just gonna allow. I'm not gonna allow like. Well, you can see here I don't really have. Wait, I'm not sure if I even have support for interpolation actually anyway. I'm just gonna do this string literal without interpolation. Is it called interpolation? String interpolation? Because that means something else in like mathematics. But whatever. Interpolated. Yeah. And what is this token? What do we? Why is that the quotation thing? Oh, I see. That's the actual token. I see. But then we don't really need. Huh? But we're not checking if we have quotes here though. You know what? I'm just gonna get the next token. Actually, this would just be expect token string. Yeah. There we go. Now we have that. We're expecting that, and then we also need to say Lexeme to get the actual name out. Now I'm not sure if we need to. Do we need to duplicate that? Maybe. This is just making a slice here. Oh yeah, because it's including. Oh yeah, it's including the string. Okay. Or the quotations. Yeah, I forgot about that. So okay, parse string literal without inter. Okay, let's just make this here. And it's, I mean, it's gonna be the exact same thing actually. But we don't actually make an expression. We make we just get a string here. And you, I guess we just reuse the Lexeme here. Except, what do you do? You're just creating the expression there. Okay. So actually, yeah. So we just do return inner here, or return this. All right. So this would be parse string without interp. And oh. We actually do need to consume the next token. There we go. Toke. Okay, now we have the string there. Hopefully we can use it. We'll get a segmentation fault if something weird will happen there. Right. So it's a complaining because we're not returning anything. Okay, so we've got the import, we got the open parentheses, closing parentheses, we've got the module name, and that, I guess that's all we really need. So this would be an expression. I hate that I don't get autocompletion here. Oh, because I need to allocate it. No. How are we doing that down here? Oh, alloc expression, okay. So, okay, so self alloc expression. What's happening here? No. All right, and oh man. You can be something here. Where's the import path? What the hell? Okay. I guess since I'm gonna use a lot of like zig-like structures, we could use. I just thought of like we could use like the built-in AST and zig. I think it's like available if you do like zig. Or is it? Maybe it's not. Yeah, we got AST right here. Span. Yeah, I mean we could just use this, I guess, as well. If you want to make a language that looks like Zig, but it's a little bit different, you could just use everything here. Okay, well, whatever. Where's the import expression? Is that maybe that's not implemented yet, actually. Yeah, that might not be implemented actually, so import, we got a statement but not a, so okay, so let's look at the statement. I'll basically copy this. We need an import expression, and I'll put this over here. All right. So we got an alias. We don't really need an alias. We just need a path, module path, literal span, string literal. Let's just make this a string. You know what? Let's just make it a string. Okay. This is kind of stupid. I mean, you could just do this. You could say if it's a literal, because which is the only one that is different here, or then you could do like inline else. Span, because if it doesn't exist, then it's gonna, the compiler's gonna complain. If you need a special case, you can just add it up here instead. Okay. So now this is an import expression, and we have the path is module name. I guess this is not really the path though. Path is kind of weird. It's gonna be like name or module name, and then span is, well, it's gonna start here, so we'll get this open, or start and end. So this is gonna be start and at, no, start dot span. All right. So they were describing like where is this expression, like what part of the code is this expression at. Okay, so now we should have this expression like an AST version here. So let's, yeah, and then it should also let's add this to our thing here. Import. So basically we could do like let library import library. And there we go. Now we have a let declaration, not mutable, the binding to an identifier lib, and we have an import expression with that we haven't implemented printing for, but we could just do that. Printing. So we have let. Now these are expressions. Expression statement. Yeah, so we'll just, let's see, let's just copy this one. And we have import. Import. Render literal. No, it's just gonna be. Does this include the end line? Yeah. So this is just gonna be level +1. This is just gonna be like print. And then the module name, basically. Okay. Oh. We've got, all right. Sorry, this needs to be a tuple. There we go. Okay, so now we can see here we got import and the name is lib. All right, cool. Yeah. So, but you know, if we remove print AST, it's not gonna be able to run this. I don't think. Yeah, unsupported expression. So that's the import expression. So if we really wanna be able to run this, we have to also now teach, as AI usually says, we have to teach the program. Kind of find it funny to execute an AST, and we should have that somewhere. Like if I go to main and whoops, and we will go to dispatch, which is like where we actually runs the script. Here, run script. So here we're setting up all different kinds of stuff like module registry, some tracing stuff, environment, I guess, things. Yeah. And I don't know, expose script method. I don't know what this is. This is all like AI stuff, AI generated stuff. So I'm not sure what's happening here actually. Expose script method is like doing some things. Okay, so we're just setting some environment variables. Okay. Ensure executable there on path. Sure, why not? We have a script directory, so we know where we are. And some tracer stuff. All right, I'm not. Okay, and then we have this command runner, which should be what we're interested in, maybe. We open the file and read it. So this feels like this should be part of, you know, a more generic function that would read in a file and then produce an AST instead, or even maybe we have some sort of pipeline that you can configure to stop at the token level or stop at the AST level or whatever, maybe something like that. But this just happens straight up in the run script function, which is like the entry point of the whole program, basically, for running the script. So this is where the AI was kind of, yeah, not really doing what I wanted it to do here. Print script tokens. So this, I assume, only happens if we actually want to do that. Yes, because we don't really want to do that. And then also, if we want to do it, we don't actually want to do anything else. So it's like if config print tokens, we run this, and then we also return 0 because it went well. Return, and here is like return is actually the exit code of the program. That's how AI set it up here. So it feels more like a C program now, I guess you could say, like the main function in a C program. One second here. All right. Okay, so let's see. Okay, so and this is like the old thing. So this is kind of weird how the AI did it, because it's like it made this weird one-off function to register inline function. So basically, first it made a kind of pre-pass on the script, and it read all the functions and registered them in the registry, and then used that registry like to execute the script later. I think it just skipped, I guess in the execution it just skipped all the function declarations, I guess. But this is now like old disabled code. Here we declare function binding, so it read all the functions and declared them in this registry here. That's not how I really wanted to do. What I wanted to do is read in the file, parse it as so tokenize it, build an AST, then I want to run some static analysis on it for like type checks and stuff like that, and then run the script basically. Yeah, so I'm not sure. Yeah, it did something else here. So let's see. Script AST, yeah. So here we have this function, parse script. So this is the one we've been modifying here. So parse script basically takes a bunch of statements, puts them here. Each statement is this one where we have a let statement, a let binding, or we have an expression. That is what we have right now. Okay, and then when it has the script, we get an AST. We also do some stuff with the error. We should really maybe put this in like a handle error function. Yeah, this is way too much. Actually, where is this? Like handle error, handle parse script error. Contents. Yes. Standard error. So that's just a rider. Yeah. It's standard. I really like how they changed the rider interface, because it's so much easier to define these functions now and reason about it. So you don't have to deal with all these different kinds of riders and stuff. Yeah, so this would be like handle error, parser, contents, standard error. I'll pass in the error as well. And a script. What the hell is that? Script. Script invocation. Okay. Great. And that is, where is that? Command runner, maybe? No. Executor. That's script invocation. It's in CLI config, okay. I guess it's like how it was invocated or something. And we also need the error as well. So error is any error. There we go. And we need to supply the script. All right. And I guess, well, let's just pass it as a pointer, just to make sure nothing weird will happen. I guess I'll put const here, just in case. Error write failed. We'll do that. Expected. Well, okay, so do we have different exit codes? No, we don't. So we'll just, actually, we'll just do this, then we'll return one from here. There we go. Error unit. Oh, this shouldn't be able to. Okay. Okay, I guess we'll catch this error as well, and then I just put an error here. Could not handle error. All right. And then like original error we can also have as well. There we go. All right, cool. So now we've done that, I'm just gonna, oops, rebuild here and test this. There we go. Okay, so just so we don't have all this crap in there. It's actually a little bit harder to, like when you want to refactor those things, especially if you need all this crap, you have to sort of, yeah, there's a lot of steps involved to refactor that, but yeah. It'll probably be easier to put all the things in a struct instead. Then you could just refer to the struct, and you could, yeah, you don't have to pass in everything like that. Okay, anyway. And here we have print script AST, where we also print the script AST if we need to. If we want to print it, we don't actually want to execute. So I'm gonna put this there, and I'm gonna return 0 if we want to do that. over here we can do, one second. Let's see, we can say, well, that we don't need to have this bool here. I'm just gonna move this part away. It's kind of in the way. I'll just put it down here. And then over here we don't pass this in, and we don't have this, and we don't have this. There we go. All right, cool. So we got the tokens, the AST, and then we have this executor. So this is the part where we need to wait. No, we're just initializing the executor, and then we have, I'm not sure what is this doing. Reseed from context. What is happening here? This is probably some kind of lingo that is like maybe familiar with interpreters or things that I'm not familiar with, but it's also interesting. You get these information where when the AI knows something here that you don't, and it's good actually. You do get some more insight into, you know, the patterns and stuff. So what is happening here? We get a scope stack. So is this like for the actual values of this in the current scope? I guess. Frame. Binding. Yeah, we have a value. Okay, cool. And then a context. And we have a fresh. Okay, so this is basically to do with the scope, I guess. But this is like an entire new scope. Well, I guess maybe it does some kind of initialization there. That's good to have. Well, but this is the test. Where am I? There we go. Wait, execute snippet. Yeah, I have no idea where I am right now. Let's just start over. Run script. Yeah, it feels like the AI made like a lot of different versions of running a script or something. So it did like the REPL thing, and then running a script, and then importing a module was like a different part of the program. So all these different kinds of ways of doing things. But anyway, now we're back here. So we have this executor. It's populating the scopes or whatever, and then we do the actual execute with everything that we have so far. So let's go in here and see what's happening here. Handle special statements. What is that? So I've never seen this code before. This is all like AI, everything. Function declaration. Okay, import statement, execute, import. Right. So this is a special. So if we have special cases. See, this is what I mean. Like it did all this weird stuff with the let bindings. Like what I wanted to do was I wanted to be able to bind a, so you have let identifier equals and then import something dot something. So you would basically bind something to the import, to one of the exports of the import. But then it did this kind of special case let binding handle import member, like it did all these weird special cases when all it had to do was basically the import is its own expression, and then you evaluate that to get like whatever module you get from that, and then the let is just a normal let binding to the thing in that module. But it made this kind of weird super special thing here. Holy shit, this was not simple either. Member spec, extract import member spec. I mean, I guess we would have some sort of but basically how I want it to be is the modules, it's gonna work like zig. So in zig, like each file, it's its own struct type. So every function here, well, not this function because it's not in the top scope, but if it's on the outermost scope, like over here, it would be a function declared on the file struct. So the whole file, it's its own struct. So it's very simple. You import a file, that just means that you read the file as a struct type. And so everything that a struct can do, you can do in the file. So basically that just makes modules super simple. Because yeah, you don't have to have this weird member spec. You just read the struct type, and that's what you get from that. So so here it did some super special stuff for the modules. Okay, I'm maybe just gonna ignore all this crap here, and what I'm gonna do is I'm gonna put off the import a little bit. So let me do this. Okay. Oh, what's going on now? Print script AST. Oh, there we go. Okay, so what I'm gonna do is I'm gonna run this now. Okay, it doesn't do anything. Okay, so I want to make sure that this works first, and then worry about the import. So this basically, the only thing it's doing is what it's actually doing is this command down here. It should actually execute this command, but it doesn't. So let's see why that is happening. So first of all, we could run print AST. Do I have to put it here, or there we go? Okay. Okay, so what we have down here is basically we have an expression statement with an identifier echo, and then an expression statement with a literal string with only one text segment hello. So that is already a red flag here, because this is actually like a command. You know, we're executing the echo command here. So, but it is going to be a little bit tricky to know if we are executing a command or what are we actually doing here. So yeah, I guess this is one of the reasons why like bash script, like those kind of scripting language has you know, a special prefix for the variable, so you would know if you're calling a function or if you're dealing with a variable, or if you want to call like a command, or what are you trying to do here. But I'm gonna try and make it so that you can actually mix and match. You can do, you know, you can begin with result and then equals to, or mutable, and then equals to 3.5 or whatever. So you should be able to do this and have it not be a command, but this would be a command. So basically, I guess everything that is not identified as some kind of variable or anything, it's gonna try to execute it as a command instead. And it may also be a little bit about security, because you could technically redefine echo to be something else. You know, if you could do something like this, you know, it could it could be a problem. Also, this would just execute this, you know, immediately here. But you get what I'm saying here, like some sort of security. Also, accidentally, you know, mistype or something like that. Could be catastrophic, but whatever. It's just a toy language anyway, so it's not gonna get like used or anything except by me. All right, so let's see. What do I? So I want to fix this error. I want to make this. So what I'm gonna do, last thing I'm gonna do here is I'm gonna fix so that this echo hello is ran as a command and possibly even interpreted as a command in the AST. It's gonna be a bit hard though, because the AST doesn't really know if it's a command or not. However, it does know that this is not really two separate statements, so that shouldn't be two different statements. That is kind of weird that it's doing that. So I'm gonna look at the AST here. Let's see, parse script, parse statement. Okay, we have parse expression. So yeah, this parse expression should include multi, I guess, kind of multi expressions, like running a command. I guess technically you could do this. Now in Bash, this would create a sub shell, so it's not really the same thing. I'm not sure if I want to have that. I don't want to have this. I want to be able to create subshells, but I don't want to have this syntax for it, because it's kind of really ambiguous. You're really just saying like, yeah, it's a parenthesis. So you should just it's just a marker for how to, in which order to evaluate stuff. It's not supposedly subshell. I'm not that good in Bash, by the way, so I'm not sure if this. Well, this is. I think this will be a subshell in Bash, but it's really ambiguous. Like, so I think I want, if I want to have an actual subshell, I think I want to do something like this, or I'm not sure. Like, yeah, something like this instead to make it like, yeah, this is a separate thing. But yeah, we'll see how we want to do that. Okay, so echo hello. So let's see how this. I'm not sure why I rebuilt this, by the way, but oh, unexpected token. Okay, so what about the tokens? Are you? So we have parent string. Okay, well that's fine. It just says that it's unexpected. So I think what it's doing is it's trying to read this here and then an expression inside, and then it like consumes this, and then it's done because this is an identifier, and then the next statement starts here and it reads this identifier or this string literal as an expression. Then it goes over here and it's like, well, I encountered like some weird close parentheses. This doesn't make sense. Something like that. I don't know. Anyway, okay, let's just get rid of this. So what I want to be able to do is this will be one expression, not two statements, or one statement, not two statements. And it's basically going to be like, if you have a new line, that means you're on a new statement. That's what I have right now. Imagine a scripting language for your own game engine. Yeah, that would be cool. I mean, you could just use like something like Lua or something. This is more for, this is like explicitly more for, you know, Bash-like scripting where I want to be able to run commands, do things with processes, coordinate things between and stuff like that. Because I run into that issue more and more lately where I want to build, you know, more like custom tools and custom workflows and stuff. And then the Bash scripting language is like a huge barrier because I never know how to do stuff in Bash. I always have to look up, even if I've looked it up like 100 times before, I always have to look up how to check if a file exists, how to check if you know, a directory exists, because that's two different commands. And what's the difference between having an if with no with parentheses, or an if without parentheses, an if with square brackets, if with double square bracket. Like there's so many different things happening in that language. I'm always like struggling with it. So I just want to make my own language instead, and just use that, and then hopefully get rid of that problem once and for all. Okay, there might be other, you know, scripting languages for terminal-based stuff that I just like building languages as well. So yeah. So I'm doing it both for being productive, but also, you know, for fun as well, which is the best combination. Okay. So we have primary expressions, so that is kind of weird. I want to be, so I want to do like if we have an identifier, I want to try and parse Alright, so I want to try to parse a command, but that's not really an expression. I mean, it is an expression though, because you want to be able to assign to. Yeah, it is an expression actually. So I want to, but it's like, if we start with an identifier, it could be an assignment, it could be a reassignment, it could be a command, so it could be different things. So I'm gonna, it could also just be the identifier. So I'm gonna call this like parse identifier expression, maybe. It's kind of weird, ambiguous name. But yeah, that's just how it's gonna be. So parse identifier expression. I was thinking like identifier start or at start or something, but alright, that's gonna be an expression. Alright, so either we just have an identifier and then the new line, or the end of the current thing. You could be inside a parentheses. You could be, yeah. I guess this would have to be a part of that. Well, first we know that we have the identifier, which is gonna be try self-stream next. Alright, so we have that. Then we're gonna peek the next one. There might not even be a next one. I mean, it also is possible that this is like the end of the stream. But yeah, let's take one step at a time. So we'll look at the next one. So let's look at the tag here. Now, if this is like a closing parentheses, we want to basically just return the identifier. This is just gonna be like, I'm gonna return here, and this is gonna be no, self-alloc expression identifier. You should have like a span, and what is happening here? Name and span. So name is identifier lexeme, and span is identifier span. All right. We should also do that on a new line. Yeah. Or I guess technically also on like a right bracket as well, or a brace, I guess, or a comma. Yeah, there's a lot of end of expression things. Okay, if we don't find anything else, or if that's gonna be like an unexpected token or something. Okay, but then we could have strings, we could have interpolations, other variables, but I'm just gonna do like a string literal. Is this even, yeah, this is that. Okay, and then that's gonna be actually this would be like a while. This would be like a while. So this would be like command arguments or arguments. Really? So this would be a list of some things, tokens maybe? No. Call argument. Label, value, expression, span. Label. Okay, sure, why not? Arguments, we will defer, initialize. Allocator. Alright. And then at the end, we wanna do stuff with that. But let's do like while true. We'll move you into there. This is the next token. I'm gonna rename you next token. And then we get an expression out. No. I guess we could do this actually. We could actually do this. So either we get this parentheses, brackets, so that's like the end of this, and then we just get an identifier expression, which could be a command, right? That's the next token. And then we also, if we get that, we probably want to, no, we don't want to consume it. We don't want to consume the next one. But then we actually do return here. If we get anything else, we're done. Actually, this could also be like end of file. Yeah. There we go. Also, let me put this in a thing there. So we have next token. All right. I'll make you mutable so I can reassign you down here. There we go. No, you don't shadow anything anymore. What? Oh, it's a function name, right? Next token. There we go. Okay, so if we're at the end, we just have an identifier, we return that. Otherwise, we actually have like a, you know, a some sort of argument thing here, so some sort of command here, basically. So if we reach the end, no, yes, then we exit the thing, but it's not going to be an identifier expression. It's actually, it's going to be a like a command or something. I'm not sure. A call. Yeah, call expression. And what do we have in the call? We have a callee, arguments, and a span. So the callee is gonna be expression identifier name is identifier like same, span is identifier span. Okay, and then arguments, I think, no, arguments is gonna be, oops, yeah, so that's gonna be like copy to arena, call arguments, and the values is args to own slice, no, just items, because we're gonna deinitialize it later anyway. Alright, so we're copying that. Okay, cool. And then with the span as well. So the span is gonna be like, we start at the identifier and then we end at, I guess the last, I guess the next token, or we at the start of the next token. No, that doesn't make sense. We need to have the, like the last token. Right? Yeah. And then we will, well, I guess, no, that's fine. And this would be the last token, not span. Okay. And this would just be returned. Okay. So we're looking through all of this. If we find an end to the expression, we will return the expression with a call expression and the arguments. If we, I guess this could technically, this should also technically be a call with like no arguments, perhaps. Yeah, maybe. But if we find like a literal, actually, also we need to know if we're gonna, if it's gonna be an assignment as well. Like we don't know. So let's just, I'm gonna have a to-do here. Support assignments and other expressions that start with an identifier. Alright. Then, but if we get a string literal, what we want to do is we want to go into args, we want to append, and whoops. We want to oh my god. We want to append. What do we want to append? Man, this auto completion is so weird sometimes. So we have a value, it's going to be null, or I mean the label. Is it actually null though from... I'm just gonna do this, make it easier to create this one. Okay, so the value is gonna be, so what is that? That is an expression, I think. So this is gonna be like, yeah, alloc expression. Actually, we're only peeking, right? Yeah, so this could, we could just do parse string literal. Oh, but we also, okay, so we do need to consume it as well. So string literal is gonna be try self string next, and parse string literal. You need span. It's gonna be string literal span. Oh wait, you don't need. Yes, you do need span. Span. Now this would just be. Actually, this would just be like this. String literal expression is gonna be try self parse string literal, and we get a token like this. And then you will be string literal, and then string literal, that's fine, there we go. Oh, I need to do this, okay. Alright, so we append that, we also need to do a try there, there we go. Let's see, we don't care about that. No field name arguments in union expression. Oh, there. Wait, no. No, yes. This should be like this, or no, like this, yeah. Okay. And then arguments. Copy to arena. What is missing here? Callie. No wait, this should be put down here. There we go. Or wait, what am I doing here? This needs a span, but this has a span. That is that. Okay, that is that. And then we have arguments. Oops. And the span of the entire thing. Okay, there we go. There we go. Alright. Try, please. Okay. That's it. So now possibly we have support for making a call. So I will compile and look at the AST. All right, so here we have a call. So we don't have the printing implemented yet, but if we run this, Whoops. Nothing happens. Okay. So last thing now. Last thing. I'm just gonna make it run the command. Hopefully. All right. We got this executor. Execute. Where is handle special statements? I think this is the part we need to look into here. Execute let. I'm gonna remove this because it's not gonna be a. No, yeah, it is a statement. What am I saying? Expression. Yeah. So here, oh. Pipeline. Oh, wait. It's called a pipeline. Right. Render command part. Oh. Yes, we do have a whole bunch of stuff already for this. Maybe this is the part where we need to do stuff. I'm gonna do switch on expression. And if it's a call, something's gonna happen. Evaluate expression, evaluate pipeline maybe. No, we just evaluate it. I mean, I guess we could just evaluate the entire thing. But this doesn't really have like, okay, so the pipeline. I think this is kind of what we need to do here. We need to do like a pipeline, actually, not a call. So this would be like, oops, a pipeline. We have a stage, so we basically only have one stage. I'm just not gonna support multiple stages right now. So we're basically just gonna have one stage. Is it stages or what was it? All right, let's do. So we have stages. We're just gonna have one stage. This is gonna be like self arena allocator create. No, not create. Allocate. Pipeline stage 1. So we're just gonna have one stage, and then I mean technically you would look at the token. If it's a pipe token, you would create another stage. So, but I'm not gonna do it right now. I'm just gonna implement the one so we can get this running here. So we got the stage. So this is now ready to just be used there. That's gonna be put in there. Okay. Then the only thing we need is a span. No, but we need to. Yeah, we need to create the stage. So this would be like Okay, so what is a pipeline stage? We have a role, payload, and span. What the hell? Okay, command, expression. Okay, command, invocation. Here we go. There's a whole bunch of stuff here. Whoa. Okay, let's just get through this. So we have a pipeline stage. This is a AST pipeline stage. Okay, we have a role, which is a command. We have a payload, which is a command that has a whole bunch of stuff. The name is going to be identifier Lexine. We have arguments, which is a command part. So I'm just going to copy to arena. This is a command part, and the values is args items. Okay. Then we have background. Oh yeah, if it's gonna be running in the background. False. And then capture directive, I'm gonna say null. Span is gonna be identifier span and at last token span. And then we have this is gonna be empty, and this is gonna be empty. There we go. All right. So that is the payload, and then we have the span, of course, the same thing. So identify span and at last token span. All right. Now we can remove all this. And now you, let's see. You are command parts. And this. So what is a command part? Oh, the name is also a command part. Oh. Wait, I thought this was a string. No? Okay. Well, this is just a string. Wait, what is a word? Text and span. Okay, so I guess it's a word. Identifier span is identifier span. It's a little bit hard to see what's going on here, but I'm gonna try and make this. I'm just gonna do this. There's a lot of nesting also going on here. There. Redirects. Okay. We need one more, I think. Wait, something weird happened. The role. What happened? Span equals identifier span. Oh, here. Right. The word. Okay, text. There we go. Okay. Now, that is the whole thing. Wow. Okay, so then here we also need the command part. Needs to be something here. So we need this to be. Yeah, it's gonna be a string. So that's gonna be string. I mean, we could just pass in the whole string literal actually. So there we go. Oh. Wait. Is this? No, that's just a tag. Parse string literal. Pipeline stage. Yeah, that's the one stage. And then we need to return look, expression pipeline. Wait. Yeah, this is one stage. We need to return a pipeline of stages. Stages span this again. And then stages 0 equals to stage. Okay. Now the only thing is down here, expected string literal found expression. So this returns an expression, but the expression is a string literal. I guess we'll rename you to expression. We'll create another version that actually returns a string literal instead. And we'll do the same thing, except we return this. And then you can just do this. There we go. Oh. There we go. And then you should be not an expression, and also that. Okay, we get the string literal. That's a string literal. Now that's all good. What's your problem here? No field name RxC union frontend command part. What's it called? Arguments or something? Wait, in command part. Oh, wait. There we go. Okay. Wow. So here, actually, let's just evaluate everything, I guess. Evaluate execute expression. I guess we just return that. Okay. There we go. We can build it. We can... Yay! Okay. All of that for being able to run this. Cool. Yeah, and now we can see we get a pipeline here instead. So, and then technically, because it's a pipeline, you know, you can pipe it, and you saw all the other stuff there. You know, redirects, whatever, however you would do that. Like, I don't know. Yeah, whatever. And yeah, so that's gonna be interesting to implement as well. All right, but yeah, that's gonna be it for this time. So thank you very much for joining me here, and we'll see what happens next time. So yeah,